Hi everyone. Here we are going to present our presentation Industrial Regulation 4.0 in Medical Aesthetics, a model for image classification in hair transplantation. So first we introduce our group member. I'm Tasnuba Kanu, and this is our group leader, Yak Bun Hui. And the next one, Mozammel Haq, and the next one, Ahmed Amin Hassan, Ali Hassan, and next Siratul Muntaha, and Yaquin Shi. My another member is not present currently now. Member is Shobana Akeban is not presenting here. Later she will join. Now I present executive summary, which has features related to follicular unit via classification method based on ResNet implementation in fast artificial intelligence library according to the number of hairs in several follicular unit images. There are two classifications, one is defected and another is unintended defects. So the problem is that inaccuracy of the result caused by unintended defects in the outline profile of the follicular unit. So the solution is develop an optimal model so the training loss remains smaller than validation loss. Also develop image processing model by taking images as input, producing output as the predicted probability for each of the categories. And the outcome is to quantitatively examine the effects of various tactics in the discipline of hair plantation surgery.
Okay. Thank you very much, Tasnuba. Then I will start my part, its introduction. Hair transplant is a surgical operation that moves hair follicle from one part to another part. Okay, it is mainly used to treat of baldness in men and women. There are a few techniques mainly used in system. Hair transplantation is specifically follicular unit transplantation and follicular unit extraction. And in standard follicular unit, hair unit transplantation is the first start process, and regulation and method involves the extraction of the hair follicles and one by one from the safe donor location located by the occupation region of the scalp and implantation the right way after extraction. Here, statement of the problem leads to the problem statement. And the transplantation being done manually with the use of medical doctors' expertise to do hair transplantation, and this there is a high risk of human error may occur. Therefore, there is a need to implement a machine learning algorithm to use a human error. The research objective is, they have three research objectives. Number one, to calculate and explain the accuracy rate in the robotic hair transplantation process. Number two, to identify best model of current industrial revolution 4.0 practiced by medical aesthetic, a doctor primarily for the robotic transplantation process. And number three, to implement a machine learning algorithm for the classification method in robotic hair transplantation process and show the improvement of the accuracy in FUMS direction. Then I would request to my next team member to continue their part.
So in the literature review, we done some study to compare FUT, the follicular unit transplantation using the strip surgery versus the follicular unit extraction FUE. So in terms of the human resource, FUT is a simpler procedure, whereas FUE require a long learning curve for the surgeon. In terms of the duration of procedure, FUT is much shorter and the complexity is less, whereas FUE is more time consuming and more laborious in extracting the intact the follicle unit. However, FUT has will leave a visible strip scar and it takes longer healing time for the post-procedural discomfort for the patient. The last comparison is regarding the risk. FUT is less risky, whereas FUE will cause a higher risk because the damage during the implantation could be higher.
Global studies have started for the hair transplantation since 1989, but the burning topic in this recent decades is IFHUT. That's the new thing, that instant follicular hair unit transplantation. So keeping pace with the Industrial Revolution 4.0, the hair surgery transplantation has also advanced. So we're going to talk about the image classification for the hair follicular unit translation calculations. So there is a triple scan that's been developed by Hoffman, and then there is another contouring based identification, and then there are some other algorithms that gives 83% of the accuracy for classification of the follicular unit classifications. So there are so many classification methods that are giving the satisfactory results. So but nothing has achieved 100% yet, the accuracy for calculating the follicular units of the hair. And there are some surgery in robotics like the ARTOS and NewGraft. The NewGraft is basically a handheld device, is operated by the surgeons, and then they use it for assisting the operations for the hair restorations. But the ARTOS is the new cake right now. It actually helps the doctors for counting the follicular units of the hair, so they can extract well, and then the robot uses the 3D imaging in macro level. So the thing we are gonna try to do is enhancing the accuracy of the image classification by our method. So our next member gonna come and explain the methods we are using.
So I'm going to talk about the research methodology that we propose for this research. We propose to use a quantitative design, and we will use an experimental method. We will have a data set of about 500 images of donor areas, images of donors of the donor area at different patients that we have collected from different hair transplantation clinics, and we're going to implement and build a classifier, an intelligent classifier using neural network, artificial neural network, based on the fast AI machine learning and image classification library, and we're going to compare the accuracy and the results that we get from this classifier with the current classification methods that is existing in the market and that is used by some commercial systems. Our hypothesis is that using artificial neural network will have a much more accurate results. Thank you.
We have successfully established the method and the procedure whereby the IFUT process can be taken off, which includes of 5 steps of pre-harvesting and 4 steps of implantation. We also have suggested the integration of cloud and IoT device to be integrated into this project so that it will support the Industrial Revolution 4.0. With the help of deep learning and machine learning, our accuracy and the throughput level has increased. With IFUT, we also achieved a higher success rate whereby the patient could come regularly to attend the session to do a gradual inspection. From thus, attending a few sessions will help to reduce the failover and increase the success rate for this process.
For my part, I'm going to do the conclusion for my proposal. So my proposal will be having a new model on the identification of follicle unit classification. So based on the images collected 500, we are going to use the ResNet implementation from FastAI Lab. Using this different evaluation method and the neural network algorithm, it is proven that it outperforms all other classification algorithms in terms of the accuracy. So when we experimented it with the same dataset, the expected result is different from the current digital imaging used by the industry. So it's confirmed that machine learning model, especially neural networks, is superior to those other algorithms in image classification. Okay, thank you everyone.